Here, this is a physics problem which can be solved using a differential equation. So, a stone is dropped from a 100-foot high building. Find as a function of time its position and velocity. When does it hit the ground and how fast it's going at that time? So the first step is to mention what this problem wants. Here we want position as a function of time, that is s of t, and velocity as a function of time, that is v of t, and then the time t that it's gonna hit the ground, and then at that same time how fast or what's the velocity at that time. The second step is try to draw the problem. So we're gonna start drawing the ground, and then from 100 feet the stone going to be dropped. Noting here the initial position gonna be 100 feet from the ground, and then at the ground the position gonna be equal to 0. And the initial velocity v of 0 gonna be equal to 0 since it's dropped, it's not thrown. Here velocity is a vector, therefore I'm gonna choose the direction of the velocity to point up. Noting here the only force that's acting on the stone is weight, and gravity gonna point down opposite of our velocity direction. So I'm gonna start with dv dt, which is the change in velocity equal to minus g. Why it's minus g? Because g is pointing opposite to the direction of the velocity. Here gravity of the earth gonna be in feet, so it's gonna be 32. Now note here velocity as a function of time gonna be the integral of alpha prime of t, that is the integral of minus 32 dt. That's gonna be equal to minus 32 and then t, since this is the velocity of a constant, plus c. Here what I'm gonna do, I'm gonna use the initial condition for the velocity, v of 0 equal to 0, to find the value of c. So I'm gonna plug t equal to 0 and v equal to 0. Here c gonna be equal to 0. Therefore, the velocity as a function of time gonna be equal to minus 32t. Noting here, the velocity gonna be equal to change in position, that is ds over dt. Therefore, ds over dt gonna be equal to v of t, which is minus 32t. Now we want to find the position. Therefore, it's gonna be the integral of s prime of t. That's gonna be equal to the integral of minus 32t dt. That's gonna be minus 32 multiplied by the antiderivative of t, which is t squared plus 2, and then plus a constant, which is k in this case. Therefore, s of t gonna be equal to minus 16t squared plus k. Here, to solve for k, I'm gonna use the initial condition for the position. Since at t equal to 0, the position is 100 foot from the ground. I'm gonna able to solve for k equal to 100. Therefore, the position as a function of time gonna be equal to minus 16 t squared plus 100. Now, when the stone going to hit the ground? Notice it's gonna hit the ground at s equal to 0. So I'm gonna use the position equation and plug s of t equal to 0 and solve for the time. First, I'm gonna move minus 16t squared to the other side, and then I'm gonna divide both sides by 16, and then I'm going to take the square root of 2. I'm going to take the square root. Right here we have a positive and negative value of t. Time is only positive, so I only take the positive value. Therefore, t gonna be equal to 2.5 seconds. Now, how fast that gonna be at t equal to 2.5? I'm gonna use the velocity equation and plug t equal to 2.5. It's going to be minus 80 feet per second. So the speed gonna be 80 feet per second, and note here the negative signs mean just it's going downward since we choose our velocity to point up.